Hi dear students, welcome to the next beautiful topic from electrostatics, and which is actually the continuation of electrostatics, potential energy and capacitance. Okay, there are a lot of questions are already came for Neet and IIT JEE examinations with different combinations from this one. So from the previous word itself you might be thinking about the topic, right? Combinations, which means we are going to deal with combination of capacitance and its various flavors. Okay, so let's start. So write down our head, the first heading, combination of capacitance. So combination of capacitance, this is our topic here. Okay, so we'll say what is combination of capacitance. What this actually indicated to us, combination of capacitance. Combination means there are different ways in which generally, okay, generally suppose you can assume like you have some bricks with you, or you have some, in a very simple way, you have some soap box with you. So you can arrange one box, next box, next box, next box. That connection is called series connection. You can arrange one box, and on top of that you can arrange another box, on top another box, on top another box. So all the right hand sides will be here, and at the same time all the left hand sides will be here also. Such a type of connections are called parallel connection, a stack like this, and in this way, one box here, second box, third box, fourth box. If the connections are in like this, in like a row, then it is called series connection. So we are going to see two type of connections will be here, series connection and parallel connections. Okay, so what is called a series connections and what is called a parallel connections? So what is actually a series connection and what is actually a parallel connection? So first we are going to see one type of connection, then of course we have to move to the next one. So the first one is called series connection. Series connection. So write down the heading series connection. So we'll take some examples. Okay, so I have one capacitor, I have second capacitor, I have third capacitor. So this capacitor is connected with one voltage source. So this is C1 capacitor, C2 capacitor, and this is C3 capacitor. All the capacitors are supplied with a voltage called V. Okay, if there is a series connection is available, then the voltage whatever I am giving will be here, will going to split. I will tell you an example. For example, if 10 volt I will give here, suppose this is taking 2 volt, this is taking 6 volt. So how much it is totally taken? 2 plus 6. How much balance will be there? 10. So what is the total voltage will be here? 2. For example, if this is 3 and this is 2, then this will be how much? 3 plus 2, 5. So we need total voltage equal to 10. So what is balance? 5. So 3 to 5 is the voltage across this one. So what I am trying to convey to you here is total voltage, whatever you are giving here, this is your total voltage. This total voltage is going to split in a series connection. This is called series connection. Sorry. Okay. So voltage will be splitting across in a series connection. Parallel connection, voltages are same. So we'll write our first point, voltage split in series connection. Voltage split in series connection. Voltage split in series connection. First point. Second point, voltage same in parallel connection. Same in parallel connection. Same in parallel connection. Parallel connection. So these 2 points you have to remember in the entire physics. If you are learning, if you are learning electrostatics, electric charge potential, capacitance, electrical potential and capacitance, the second chapter, and if you go to current electricity, if you are learning about magnetic effects of current, and further, and the last chapter, semiconductor electronics. So if you are going till the last moment, you need these two concepts, voltage split in series connection, voltage same in parallel connection. So this is a series connection. So what will happen? Voltage will split. So you have to remember these terms. So voltage will be split in series connection and voltage is the same in parallel connection also. Okay, so these 2 points are important here. Now we'll see. Now we are assuming the total voltage is not 10 volt. 10 volt I have taken as an example. I have given a V voltage. So what is the voltage will be here? V1. What is the voltage here? V2. What is the voltage here? V3. So I can say total voltage is equal to V1 plus V2 plus V3. This is my total voltage. So we'll simplify. So V is equal to, so what is the relations between voltage and capacitance? Okay, we know Q is equal to CV or V is equal to Q by C. We know these equations. So we'll write it is Q by C. Okay, so total voltage I am giving. So I can say total charge and total capacitance is equal to, or normally we'll say effective current and effective capacitance. Effective total, total or effective, all are same, is equal to what? What is a charge? In series connection, if one charge is flowing here, the same charge, the voltage capital V will give a charge equal to Q and the same charge will flow, will be over here. So Q by C1 plus Q by C2. Okay. Q by C1 plus Q by C2 plus Q by C3. Okay. So what will happen? This is the total charge. So Q effective is also equal. Effective means what is the charge coming from the battery. That is also called Q. All the Q will get cancelled from both from LHS and from RHS. So what is the total C effective is equal to what is coming? 1 by C1 plus 1 by C2 plus 1 by C3. This is called the effective capacitance in case of a series connection. So this is very important. So in series connection, you have to remember total capacitance 1 by C effective is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Here I have taken 3 capacitance. If you have more than 3, then 1 by C4 plus 1 by C5, 1 by 6, it will continue. But here in short. So these 2 points are same. Voltage is split in series connection. Voltage is same in parallel connection. Here I have to add 1 point. Charge Q. Charge, or I also called current. Current is required in current electricity. So charge or current is same in what connection? Is same. The charge will be here, same charge here, same charge here, same charge here. Is same in series connection. This is important. Is same in series connection. Current or a charge or current, Q bar I. Don't write like Q by I. No, I mean to say Q bar I, which means Q or I both will be the same in cases the charge or current split in what connection? In parallel connection. In parallel connection. So what from this statement you can see, these are controversial statements. For example, voltage is split in series connection, but current or charge will split in parallel connection. So voltage and current splitting in both contexts. Voltage is split in series, but current is split in parallel. Voltage is same in parallel, but current is same in series connection. So these 2 points are really important while you are going forward. So hope you understood the combination of series combinations. We'll move to the next, the subsections called. So series means, of course, you know. Okay, what is the next one? Parallel combination, but the concept will be the same. Concept will be the same means in series connection voltage will be splitted, but in parallel connection voltage will be different, or opposite way. In parallel connection voltage will be same. In series connection voltage will split. Charge or current is same in series connection. Charge or current will split in parallel connection. So the concept will be the same, but we are going to see the next one with the same concept. Concept is not changing. Parallel connection. So parallel connection. So we will connect again 3 capacitors in parallel. This one and this one. So I connected. This is connected with a battery, V volt battery. this is C1, this is C2, and this is C3. So what will happen will be here, I am giving charge Q, charge will be splitted, total charge will be splitted Q1, Q2, Q3. I know this is Q is splitted in parallel connection, but what is same, what is the voltage here? V. What is the voltage here? V. What is the voltage here? V. In parallel connection, voltages are same. I am giving V voltage will be here. I am getting throughout V voltage. I am giving Q amount of charge will be here. Here it is Q. No. Here it is Q. No. Here it is Q. No. The Q is splitted. So I can say Q is equal to Q1 plus Q2 plus Q3. Q1 is equal to Q1. So based on that concepts, we are moving forward. Q is equal to Q1 plus Q2 plus Q3. What is Q? Q is called C. So C effective into V effective is equal to, what is V effective? Total voltage is giving by the battery is called V, is equal to, what is Q1? Q1 equal to C1V. So C1V plus, what is Q2? Q2 is equal to C2V. Q2 is equal to C2V. So C2V plus C3V. V cancel, cancel. All are cancels. So C effective capacitance is equal to C1 plus C2 plus C3. As I told before, I have taken only 3 capacitance will be here. That's what you are getting C1, C2, C3. But if you have multiple capacitance will be here, your answers will get extended out. Okay, now I will ask a general questions to a note. If there are n equal capacitance, if there are n equal capacitance connected in parallel, then the effective capacitance is equal to, if there are n capacitance which are connected in parallel, which means that what? C effective is equal to, there are n capacitance. So C plus first capacitor, second capacitor C, third capacitor C, and go up to how many capacitor? N capacitor. Okay, so C plus means how will say 1C, 2C, 3C, 4C, 5C, finally how much C? NC. So total capacitance is equal to, effective capacitance is equal to NC. And the same format I can ask to you. The same format means whatever we have written will be here. There are n capacitance are connected in parallel, effective capacitance is equal to NC. The same way, if n capacitance are connected in parallel, in series, then the effective capacitance is equal to what? N capacitance. So 1 by C is equal to 1 by C effective is equal to N capacitance. So 1 by C plus 1 by C plus 1 by C plus etc. up to 1 by C. So 1 by C, 2 by C, 3 by C, 4 by C, 5 by C. Finally how much will come? N by C. So C effective is equal to N by C. But we actually need what? We need C effective, not 1 by C effective. So C effective is equal to, what will come? C by N. This is also important. Okay, if there are n capacitance which are connected in parallel, C effective is equal to NC. If there are n capacitance which are connected in series connection, then effective capacitance is equal to C by N. This is the concept behind this one. Hope you understood what is called series combination, what is called parallel combinations. We are going to do a problem. Okay, problem in the sense a numerical questions. Normally this is the model of questions which are coming for Neet and JEE examinations, and we will do couple of examples. So from the examples, you know, in my normal problems I will say example. So this example is nothing but a numerical question, so which are coming for your Neet and JEE. But first a few things we'll see. simplest one, then we'll go to more complex things. But as I told, the concept will be the same. That is, there are no differences for the concept. We'll go to example number 1. First example. See, let me draw a diagram. So I have two capacitance. I have connected a voltage. This is 6 microfarad. This is 3 microfarad. These are connected and I have given a 12 volt. Now I'm asking you a couple of questions. What is the, you can write the questions along with me. What is the voltage across 6 microfarad and 3 microfarad? This is one question. Second question, what is the charge on, each capacitor? What is the charge on each capacitor? This is one question. Second question. Third question, C1. What is the energy? This is something different, right? Based on what we have learned from the last session. What is the energy stored in the 3 microfarad capacitor? What is the energy stored in the 3 microfarad capacitor? Please note down these 3 questions. Okay, let's go and answer it. The first question, what is the voltage across each capacitor? First question. Second question, what is the, not the voltage, second question is asking about what is the charge on each capacitor, and third one, what is the energy stored in the 3 microfarad capacitor. So we know we are giving a voltage, total capacitance will be here, so I can find out the total charge. So first I will find out total capacitance. So C effective, 1 by C effective is equal to how many capacitance? 2 capacitance will be here. So 1 by 6 plus 1 by 3. We'll simplify this one. So 1 by C effective is equal to, okay, so in short, yeah, if it is 1 by C effective is equal to 1 by C1 plus 1 by C2, then I can write 1 by C effective is equal to C1 plus C2 divided by C1 C2. So C effective is equal to C1 C2, reverse volta, C1 C2 divided by C1 plus C2. I just take it LCM and simplified, that's all. So same formula I am going to apply will be here. 1 by C effective is equal to 6 into 3 divided by 6 plus 3. 6 into 3, 18. Okay, 18 divided by 9, which is equal to 2. How much? 2 microfarad is the total capacitance. What is the total voltage? Total voltage is given 12 volt. So what is the total charge? Q is equal to C effective into V. Q is equal to CV. So what is C effective? 2. What is the voltage? 12 volt. So we'll get 24. This is micro and this is volt. So micro Q charge, micro coulomb. Okay, which means from here 24 microcoulomb charges are flowing. 24 microcoulomb charges are flowing through the system. So which means that what? 24 microcoulomb passing will be here. Next one, we need to find out the voltage. Okay, so hope you have written the right side. I need some space. Okay, I have space here. I can use that space. Perfect. Okay, good. So 24 microfarad. What is the charge will be here? 24 microcoulomb. 24 microcoulomb. In series connection, the same charge will flow. So I answered, I got actually the answer for B. What is the charge on each capacitor? What is the charge on each capacitor? 25 microcoulomb. I got answer for this. Next one, what is the voltage across 6 microfarad and 3 microfarad? So here, capacitance value will be here. Current charge value will be how I can find? I know Q is equal to CV. Now V1 equal to, I can say Q1 by C1. What is Q1? 24 microcoulomb. Okay, what is C1? 6 microcoulomb. So how much I'll get? 4 volt. 12 will be given, 4 will be used, will be here. So what is balance will be here? I am giving 12 volt. 4 will be used, will be here. What is balance will be here? 8 volt. So I can say V2 is equal to V minus V1. So I'll got 12 minus 4, which is equal to 8 volt. This is one option. Another option, you can also use this one. V2 equal to Q2 by C2. What is Q2? Q1 and Q2 are same, 24 microcoulomb. So 24 divided by C2 means how much? 3. So same way you will get 8 volt. So either you can use this method or you can use this method, but both will yield the same result. So voltage across 6 microfarad. What is the voltage we got? Here we got 4 volt. So what is the voltage will be here? 8 volt. Next question, what is the energy stored in the 3 microfarad capacitor? How to find out energy stored in the 3 microfarad capacitor? Energy, the formula is what? Half CV square. 3 microfarad, so we have to look into 3. So which is equal to 1 by 2 into C means how much? 3. Voltage means how much? 8 square. Okay, so how much will come? How much will come for this one? 1 by 3. 1 by 3, 1 by 2 into 3 into 8 square. Okay, I am clearing the right side of the board. Hope you have already written, or if not, pause the video and complete this part. Okay, so half CV is 1 by 2 into 3 into 64. 64 on 2 cut, so 32. 32 into 3. 2 into 3, 6. 3 into 3, 9. So it is 96 joule of energy stored by the 3 microfarad capacitor. Okay, so hope you got the concept behind this one. Is it clear? Right. So fine, perfect. We'll move to the next examples. Okay, so all examples we will find the voltage and the charge on each of the capacitor. That is the aim. Okay, the question is based on that concept only. For every questions we need to find what is the voltage present on each capacitor and what is the charge provided by each of the capacitor. That is what is our intentions. So we'll take the example number 2, the second example. Second example look like I have a capacitance will be here. So let me consider this as 2 and 4. I am giving an voltage will be equal to 8 volt. Okay, so as like we are writing, what is the voltage across each capacitor? What is the voltage across each capacitor? This is the first question. Second question, what is the charge on each capacitor? Okay, what is the charge on each capacitor? What is this charge on each capacitance? The third one, what is the energy stored in? Energy stored in where? Energy stored in 4 microfarad. This is microfarad, this is also microfarad. So let's move. Okay, so I know I have voltages available. I am giving 8 volt. So what is the voltage will be here? 8 volt. What is the voltage will be here? 8 volt. So what is the voltage across each capacitor? In parallel connection, voltages are same. I told, right? So this is a parallel connection. Throughout the voltages are same. 8 volt here, 8 volt will be here. So everywhere it is 8 volt only. So 8 voltage will be here and 8 volt will be here. So I answered for the first question, voltage across each capacitor is equal to 8 volt. Second one, what is the charge on each capacitor? It's quite easy to find it. Here Q1 equal to C1 V1. So what is the Q1 and C? C value is what? 2 microfarad. What is the voltage value? 8. So 2 into 8, 16 micro. So microcoulomb. Second one, Q2 will be equal to C2 into V2. What is C2? The second one. C2, second capacitor, 4. Voltage is how much? 8 volt. So 4 into 8, how much? 32 microcoulomb. So 32 microcoulomb is the answers. So charge on each capacitor. So we find out first charge is 16 microcoulomb and the other one is 30 microcoulomb. So I got. The last question will be here is what is the energy stored in the 4 microfarad capacitor? 4 microfarad capacitor is energy is equal to half CV square, which is equal to half into capacitance is 4 C. C means 4 microfarad. Voltage means how much? What is the voltage will be here? CV square, 8 square. 8 square means 64. Again, this will cancels with the 2, and 2 into 60 for how much will be getting? 2 into 60 for 128. Here I have made one mistake in the previous problem. What is that mistake means? 128, it is microjoule because capacitance value is micro. In the previous questions, I have made it as joule. That it's a mistakenly taken the unit. It's not joule, it is microjoule. Please correct it. It is microjoule because the capacitance is in micro. So I forgot to mention a micro there. So please mention microjoule there. There we have written joule. So instead of joule, microjoule. Here also it is 128 microjoule because capacitance value is in micro. Clear? So series combination we have seen an example. Parallel combination we have seen an example. Next we are going to see an example for a mixed combination. Mixed combination means what? There are series connections are there. There are parallel connections are there. That's all. There are series connections are there and there are parallel connections are there, and from the series and parallel connections, whatever is question is asked, we need to find out. Question may ask charges, question may ask capacitance, but this questions is similar to the one which is asked for JEE and Neet. Okay, so let's have a questions here. Let's have a question here. This is 2 microfarad, 4 microfarad, and this is 8 microfarad, and we have will be here another 1 microfarad, and we are giving a voltage is equal to 8 volt. This is a questions to you. We need to find out what is answers. Here question is like only one question is placing. What is the ratio of charge on 4 microfarad capacitor to the 1 microfarad capacitor? This was a question, which means I need to find out the charge which is present on the 4 microfarad capacitor to the charge present on the 1 microfarad capacitor. So we need to find out the charges will be here. So before going there, we'll make some analysis. Once you get some question, you have to make some analysis. Our first analysis, 8 volt you are giving here, correct? Correct. So what is the voltage will be here? Parallel connection. So here it is totally. So this side is positive. I can say here 8. This is ground. So which means between this 8 minus 0, 8 volt will be here. Similarly, this is positive. Positive means 8. Ground means 0. So the negative. So total here 8 minus 0, 8 volt will be here. Here 8 minus 0, 8 volt will be here. So we got this one. So we will we need to find out the charge. Okay. So we need to find out what is the charge flowing through this one. Then it is easy to find out. Okay. So let me redraw the circuit by combining the equal resistance. What is this? This is a parallel connection. So what is equivalent capacitance? 2 plus 4 is 6. Okay. So I can say an 8 microfarad will be here, and these combines I will get a 6. And then bottom I have 1 microfarad, and then both I have 8 volt. Okay. But I know microfarad, and what is the voltage will be here? 80. Here also 80. Here also how much? 80. Parallel. Parallel means everywhere see. 80. Okay. This is what we are seeing now. So this part combined, and we have drawn a diagram. Next one. What is the total capacitance on the upper block? Upper block, it is series connection. So upper block, C effective dash I am placing. Okay, C effective dash is equal to C1 C2 divided by C1 plus C2. C1 C2 divided by C1 plus C2. So 8 into 6 divided by 8 plus 6. 48 divided by 14. Using 2 and cancelling. So 24 divided by 7. 24 divided by 7 is the equivalent capacitance. Okay, now we have the equivalent capacitance. 24 divided by 7 is will be here. So this is a total capacitance. So I have this diagram. So far I have removed this one. Okay. So hope you have written this part. I'll keep the question as such. It will will be, so the C effective overall from here to here, the total capacitance from the topmost point is how much? 24 by 7 microfarad given. So this part I am clearing. I need some extra spaces. Okay. So 24 by 7 microfarad is a total capacitance. What is the total voltage will be there? So I know Q is equal to CV. So total charge I am considering this as an upper branch. So the upper branch, total charge equal to total capacitance 24 by 7. What is the total voltage in the upper branch? 8 minus 0, 8. So 24 into 8 by 7 microcoulomb of charges will be there on the topmost block. What is the ratio of charge on the 4 microfarad? So 24 into 8 by 7. I am not solving that. If you want, you can solve that, but that doesn't matter, will be here. So what is the charge will be here? So charge which is flowing will be here is 24 into 8 by 7 microcoulomb. Once this charge will be coming will be here. Based on that, I can find out what is the voltage will be here, right? So voltage will be here. So for the 8 microfarad capacitance, okay, I can say Q8 will be equal to C8 into V8. So V8 I am calculating. What is V8? V8 means Q8 by C8. What is Q8? Q8 means charge over here. So 24 into 8 divided by 7 whole divided by capacitance 8. Gone. So how much will be there? 24 by 7 is the voltage will be here. What is the total voltage over will be here? 8 volt. Out of the 8 volt, 24 by 7 voltage is taken by 8 microfarad capacitor. So what is the voltage across this area? Across this area means what is the balance voltage? So I can say, so voltage across the 2 capacitance and voltage across the 4 capacitance equal to total voltage minus 24 by 7, which is equal to 56 minus 24 divided by 7. 6 in the 4, 2, 5 in the 2, 32. 32 by 7 is the voltage available will be here. So here what is the voltage? 32 by 7. Here also it is 32 by 7 volt, 32 by 7 volt. I need to find out the charges over will be here. So I know voltage, I know capacitance. How to find out charges? I'm going to find out, which means charge on 4 equal to C4 into V4. So Q4 charge will be here. What is the charge will be? I need to find out the charge, right? Charge on 4 microfarad capacitor to 1 microfarad capacitor. This is the question. So what is C4? C4 charge will be here is how much? 4. And what is the voltage will be here? 32 by 7. The balance voltage will be here. 32 by 7. So we can just simplify this. 4 into 2, 8. 4 into 3, 12, 128 by 7 is the charge will be here. So this is important to find the ratio will be here. Next one, what is the charge on 1 microfarad? What is the voltage will be here for 1 microfarad? Voltage means 8 minus 0. So I can say Q1 will be equal to C1 V1 for this 1 microfarad. So what is the charge? Charge I need to find out. What is the capacitance will be here? 1 microfarad. What is the voltage will be here? 8. So I'll get 1 into 8. Question is asking what is the ratio of charge on 4 microfarad capacitor to 1 microfarad. So which means Q4 divided by Q1, which is equal to 128 by 8 whole divided by 8, which means 128 divided by 8 into 8 is 64. Answer is equal to 2. 128 divided by 64. Answer is equal to 2. Okay. See, while doing the complete step, okay, if you have any doubt, pause it the video and go little bit playback so that you will get more, again you will get a refreshment over the steps. So what I have done, quite simple. This is a combination of series and parallel connection. If you see will be here 2 microfarad, 4 microfarad. What connection? Parallel. This parallel is in series with this one. So the upper branch is completely parallel with the lower branch. So this is what is present there. Next one, 8 volt you are giving will be here, which means here also 8 volt and here totally 8 volt. So I know totally 8 volt. So total capacitance I find out in the total branch I know the total voltage. Based on that, I find what is called total charge flowing on the upper branch. So the same charge will be here. Once the charges will be reached, will be here. Based on the charge, I calculated voltage will be here. But what's the total voltage? 8 volt. So some of the voltages is gone here. This capacitance is taken. Balance voltage will be here. That balance voltage is available across this, which means same here, because it is parallel connection. So based on this voltage here and capacitance here, voltage here, capacitance here, I find out the charge Q4. I find out. So I know. So Q4 is got. Next I need to get what is the charge on 1 microfarad capacitor. To get that, here I will say capacitance will be here, voltage will be. So capacitance will be here, voltage will be. How to get the charge? Q1 is equal to C1 V1. C1 is 1, V1 is 8. So I multiplied, I got Q1. Question is asking what is the ratio of charge on 4 microfarad capacitor to 1 microfarad, which means I have to take the ratio, which means Q4 by Q1. I have taken the ratio. I got an answer is equal to 2. Okay, this is just an example I have taken from my memory. But throughout, if you are analyzing this question, so you can see I have not gone and solved much of the things, but much of the things in the sense, say 24 into 8 into 7, I can multiply, maybe I can keep it will be here. But in board examination, on your school examination point of view, it is mandatorily that you have to solve it and keep it will be the value in terms of decimal value. But in entrance examinations, do not do like that, because at some point if it is come as a fractional number, keep it as a fraction number. It will be at some point this either the numerator with the denominator at some point will get cancel it out, and the further steps will be easy for you. So this is a minor point, but keep it in mind. Do not keep while you're writing entrance examinations, NEET or JEE, do not solve it in the decimal format. If the final answer in decimal format, means final answer you can make it decimal format, but the intermediate steps doesn't make it in the decimal format. Your calculation will be complex and it's a time consuming work. So please don't do like that. Okay, so this is an example of a combination of capacitance. We have 3 examples, one purely with series combination, one purely with parallel combination, and the last example is a combination of series with parallel. Hope you enjoyed today's sessions, and whatever it is given will be there. So this is all about a combination of capacitance. Some advanced things will be there, and we will see it on the next sessions. Hope you understand, and yeah, enjoy your study conceptually. Know by heart in physics at all. So bye bye.